let's take a look at the review classwork that you did. It says at the aquarium today, Rita saw 4 more than 3 times the number of jellyfish she saw yesterday. If the difference between the difference of numbers of jellyfish seen between the 2 days was 6, how many did she see yesterday? Hopefully we identified there are 2 unknowns, and those 2 unknowns are
Owen and Rick. I mean, no, today and yesterday.
Today and yesterday. Very good. Today and yesterday. And which one did you choose to be X, Lana?
X.
Which one did we choose to be X?
Yesterday.
Yesterday got to be X. And today then would be?
3x plus 4.
Good. 4 more than 3 times would be 3x plus 4. And it says the difference of the numbers of jellyfish was 6. So what was your equation?
2x plus 4 equals 6.
Good. 3x plus 4, but minus the x would give you a 2x plus 4 is equal to 6. Of course, you'd subtract the 4 away to get 2x is equal to 2. And x just equals?
1.
1 jellyfish. So apparently yesterday, she only saw 1 jellyfish. But yet today, she saw?
7.
7. It only asked for how many did she see yesterday? Just 1 jellyfish, which is still 1 too many. You ever been stung by a jellyfish?
No.
Okay, I've never been stung by a whole jellyfish. Because growing up in Pensacola, hurricanes would come through and they would beat the jellyfish to pieces. And so there would be tiny fragments of jellyfish everywhere. Now, every now and then you'd see a whole one like lying up on the beach or whatever. You'd be like, dang, I don't want to get that on me. But even little pieces of jellyfish still sting. And so you get these random little welts on your legs from pieces of stinger of jellyfish. And so like after, it's about August usually, is when all the broken pieces of jellyfish make it up to Pensacola Beach. So we learned June it's too cold to go to the beach because the water will freeze you. It's not warm enough yet. July's perfect. And August there's too many jellyfish fragments. So July was our 1 month we could go to the beach and enjoy it. So anyway, we don't have that problem here. All right, number 10 says Owen chopped 4 logs fewer than half the number Rick chopped. And that's what you answered a moment ago was between Owen and Rick, you let Rick be X. And we represented Owen as
1/2 x negative 4.
Good, 4 fewer than half the number. This is how many they really did chop. But then it says if Rick had chopped 3 more. Well, how would I represent Rick if he'd actually chopped 3 more than he really did?
X plus 3.
So if he'd chopped 3 more, in other words, if he had chopped x plus 3, then the total would have been 74. So Rick really did only chop x. But if he'd chopped x plus 3, and Owen still chops his 1/2 x minus 4, then they would have chopped a total of 74 logs. Do you see how to set up the equation? Did you set up the equation that way by any chance?
No.
But it makes sense now. Instead of saying x plus 1/2 x minus 70 or minus 4 equals 74, they didn't really chop 74. But if Rick had just chopped 3 more, then it would have been. Now another way you could have approached it was this. If Rick had chopped 3 more, they would have combined for 74. Well, he didn't chop 3 more. So they didn't combine for 74. They would have only combined for 71.
Yeah.
And that's another way you could have set it up as well, was to think through, well, but they didn't chop 74 then, because he didn't chop those 3 more. So they must have only chopped 71, and that equation would have been fine as well, because even if you put the plus 3, you could have put a minus 3 and still gotten the 71 anyway. So either one would work here. We could try to combine the x's here, Lana, or we could say we hate the fraction and just get rid of the fraction. Which way did you go?
I kept the fraction.
That's okay, you can combine them, where a 1x, an entire x plus a half x gives you
1.5 x.
1.5 x minus 4 equals 71. Let's make this an improper fraction though.
3/2.
Good, 3/2 x, and let's also add a 4 to both sides to get,
Oh.
because it was a minus 4,
Oh.
right? So we put a plus 4 on both sides
Oh,
to get
that's-
70.
74.
Ooh, 71 plus 4?
Oh, 75.
75. And then to get rid of this fraction, Lana, we can get rid of the whole thing at once if we'll multiply by the reciprocal. Divided away, but division is multiplying by the reciprocal. So we'll multiply by 2/3. We'll put the 75 over 1. We can cancel 3 and 75. Think money. 75 cents, you divvy it up 3 ways, would be
25.
times 2 would be
50.
50. And so apparently Rick chopped 50 logs. Owen chopped 4 fewer than half as many. Well, half as many would have been
25.
but he chopped 4 fewer than that.
21.
So he's a bum. Way to go, Rick. Owen. Miserable. Or maybe he wasn't chopping very long. I don't know. The question was, though, how many did Owen chop? He chopped 21 logs is our answer for 10. Questions on those word problems. All right, and then on to something a little bit more straightforward, working on that chart with circles. Number 11, they give you a diameter of 2 inches. Lana, that means we have a radius of
1 inch.
The circumference then would be approximately,
6.28 inches.
and the area would be
3.14 inches squared.
good, approximately 3.14 inches squared. Number 12, they give you a radius of 3.5 meters. The diameter is
7 inches.
7
Inches.
On number 12? Meters?
Oh, I'm still looking at inches.
Yes, careful, 7 meters. And as soon as I see a 7, I'm not thinking 3.14 no more. What am I thinking, Lana?
21 sevenths.
Ooh, 22 sevenths. 22 sevenths, which pi, 22 sevenths times 7, the sevens cancel, gives you 22 meters. Or, Lana, you could have used 3.14 and gotten what?
21.98 meters.
Right, your answer will be slightly different because they're not either one exact, but yeah, approximately 21.98 meters or approximately 22 meters. And then the same thing, by the way, I'm going to treat the 3.5 as 7 halves. And then I could use that to find the area for the pi r squared, or use 3.14. That's fine as well. What was your area?
38.465.
Good. If you use 3.14, it's 38.465 meters squared approximately. Sorry to cut you off there. But if you did the 22 sevenths as your pi, and your r was the 7 halves, and you squared it, so times 2, cancel the 7s, cancel the 2s, you get 11 times 7 is 77 halves, comes out to 38.5 meters squared, which is slightly different than what Lana got. But either answer would be accepted. But anytime I see a 7, I'm a big fan of 22 sevenths for my pi value. Any questions on 11 or 12? All right, looking back across the page now, let's look at a couple of word problems involving surface area, like we had talked about yesterday. Number 7, read the word problem for us, Lana.
The juice box is a rectangular prism of a length of 6 centimeters, width of 3.5 centimeters, and a height of 9 centimeters. Find the surface area. Find the surface area.
All right, what formula do we need to use to find the surface area here, Lana?
SA equals 2LW plus 2WH plus 2LH.
Good. Basically, pair up your numbers, double them, and add the pairs together. So it's got 6 by 9 by 3.5. One thing I can do to help myself a little bit is to remember that whenever you multiply 3.5 by 2, Lana, it comes out to 7.0 or 7 evenly. So as I multiply here, I don't really know which one's which length with height, but it doesn't really matter. Just don't ever use the same pairing twice. So for instance, if I put the 6 and 9 together, the next time I use the 6, it better be with the 3.5. And then I can't use the 6 again, but I can use the 9 and the 3.5. When you multiply, start multiplying the 3.5 to get, you said what?
7.
7 to get.
42.
7 gives you.
63.
And then here, add up, multiply to get
108.
12, which gives you then a 108. Add them all together, start with the 108 and 42.
150.
150, and then add the 63 to that to get Not you, Lana, him. Glenn, be good.
213?
213 square centimeters square to be the surface area of the juice box. All right, questions on that? Anytime you're working with a decimal on a surface area where you can multiply by the 2 can at least cut down on decimal places a lot of times. And then number 8, read that one for us.
The surface area of a square pyramid is 480 square feet. If the length of the base is 12 feet, what is its slant height?
Now this one's a little bit more complex because they give us the surface area and we've got to put the puzzle together. What's our formula for the square pyramid? Picture it and think through what the formula would be. Would be the surface area of a square pyramid. Picture what its net would look like, if you will. On the base you have a square, and then you have how many sides?
4.
4, and each one of them is a
Triangle.
So what's the area of a square?
S squared.
S squared, or in the triangle's case, or the pyramid's case, we'd say base squared, right? And then you said we have 4 triangles. What's the area of a triangle?
1/2 BH.
1/2 BH. Or we could simplify and just say
8.
4 cancels with the 2 to give you
1, 2. Just 2.
so 2 BH, right? So B squared plus 2 BH. Well, they give us the surface area, Lana, is the 480. So that needs to go where it says SA, right? Because that's the surface area. They also tell us the length of the base is 12. So in for the B, we have to plug in 12. Well, you know 12 squared is?
144.
And you know 2 times 12 is?
24.
Times h is, of course, just 24h, right? To solve and get the h by itself, that slant height the problem asks for, Lana, first we need to...
subtract 144 from both sides.
Good, get rid of the thing that's least attached. Get rid of that 144 by subtracting it to get?
36.
336, right? Equals the 24h. And then finally divide away the...
24.
Let's see, Lana, 24 goes into 33 how many times?
1.
With how many left? And then 24 goes into 96 how many times? Well, how many times does 2 go into 9?
4.
4, let's see. Would 4 times 24 give us 96?
Yes.
Okay, then it's 4. So the slant height of our pyramid must be 14. Looking at problem 8, 14 feet.
Or feet.
Feet,
Yeah,
our answer, yeah, not square feet, that'd be area. This is just a slant height of the pyramid. 14 feet if you were walking up the side of the pyramid. Any questions on surface area from yesterday? Any questions on that at all? All right, we'll turn over to page 258 now. And we don't have a lot of time left in the hour, I'm afraid, but let's take a look at just some things that we'll work on a lot more in our next lesson on Monday. Hopefully Scott and Josh will be back with us then. But page 258, surface area of cylinders and spheres. Important to note that a cylinder is simply 2 circles at the top and bottom, and then a rectangle that's been folded around. But it's still just a rectangle. The circumference of the circle, then, as you can see on the purple diagram, would have to be the length of the rectangle, right? And then the height is the height. So if we're taking the area of a circle, we've got 2 of those circles. So for the surface area, we've got a circle at the top and a circle at the bottom. Each one is pi r squared, so that's 2 pi r squared, 2 circles. And then we've also got the rectangle that's 2 pi r in length, circumference in length, and whatever the height is. Base times height would be 2 pi r h. And this is the formula you need to know for the surface area of a cylinder. Now the lateral surface area doesn't include the circle at the top or the circle at the bottom. So you don't have the 2 different pi r squares in there, it's just going to be 2 pi r h. So make note of these formulas, they're on page 258. as far as how we would use these, you see the example problem there. They've asked for the lateral surface area first. Well, 2 times 3.14 times r, which is 3, times h, which is 5. I would multiply the 2, the 3, and the 5 first. Take care of all the easy numbers. 2 times 3,
6
times 5.
30.
And then at the end, take your 30 times the 3.14. Strategy tip, knock off a 0, knock out a decimal place. And then you get 94.2, whatever they are, centimeters, 94.2 centimeters squared. Does that make sense how to find the lateral area? And here's the nice thing, Lana. We already found the 2 pi r h. So when they then ask for the surface area, I'm going to find this and add on the 94.2 I already found. I'm not going to remultiply that out, right? So the 2 times 3.14, and we can do 3 squared in our head. 9. Here it might almost be better to take your 6.28. I think you'd asked about that the other day, right? Can't we just memorize that 2 pi is 6.28? And maybe multiplying that by 9 might be easier. That gives us
7.2, 25, 56.
And there's 2 decimal places. That's the areas of the top and bottom that we'd ignored earlier. Plus the 94.2 from that wraparound rectangle adds up to, as you see there, 150.72 centimeters squared. Questions on how to use lateral surface area and plain old surface area of a cylinder. Now, there's not a way to make a net for a sphere. Just can't do it, okay? So maybe one way to think of it would be if you could imagine having a circle, another circle, and another circle, and another. It's almost like, kind of like seeing, almost like maybe a model of an atom or something, seeing all those little electrons going out there, all making all these circles all over. Well, imagine then the area of 4 of those circles ends up being the surface that would cover an entire actual sphere. I don't know if that'll help you remember it, but the surface area for a sphere, just memorize it, is 4 pi r squared. The surface area for a sphere is 4 pi r squared. Again, you can't really net that one, just so it's more of a memorization play there. But you see how to use the formula straightforward. 5-inch radius of the sphere, meaning every single point all over the ball is 5 inches from the center. 4 times 3.14 times 5 squared. Now again, I'd start by squaring the 5 to get
25.
Times 4 comes out to
100.
100. You multiply that by 3.14. 2 zeros, knock off 2 decimals. Comes out evenly as you see to 314, rounded of course, approximately 314 square inches. Questions on that formula? All right, so 3 more formulas to memorize. For the sphere, 4 pi r squared. And then for the cylinder, you can actually picture the nets for this one. A circumference base times height, circumference base times height, plus the 2 different areas of the circles on the top and bottom. There's 3 additional formulas to add. It may not be a bad idea, Lana, to have and guys watching, to have a page where you kind of just list out all these formulas. And in our next lesson, we're going to kind of run through all of them. If you wanted to over the weekend, though, get that prepared. If not, we'll do it together in class on Monday. But good to have a page where you can keep all these, keep track of all of these. If you would, I want you to do number 1 and number 5 on the next page. Number 1 and number 5. And we'll call that good for today once we've finished that. So there on page 259, do numbers 1 and 5, practicing with each of these formulas. This is the kid who said he's too tired to jump.
I said I was too tired. Too sore. Too sore. Too hurting.
No, you don't know what sore and hurting is yet. But after PE, you'll know.
I thought you were supposed to cut your tongue. Yeah.
No, there's a little thread that's been bothering me. I keep looking down, I see this little gold thing waving in the breeze.
I knew soreness the first night of practice.
Mm-hmm.
And
Thought you knew it.
Thought I knew it
soy sounds good. That was.
Really quietly, gentlemen, if you would shut the door behind you. All right, let's go and take a look at number 1. And Lana, what did you get for the lateral surface area?
552.64
Good job.
centimeters squared.
A lot of decimals in there, weren't there? 552.64 centimeters squared. Great job. And then for the regular surface area, which includes the top and bottom bases.
954.56 centimeters squared.
Good, 954.56 centimeters squared. Very quickly, do number 5. It shouldn't take real long for you, so take just a moment to work that. You will have some of these in the homework. Want to make sure we're able to work them accurately. And this shouldn't be new to you. You did it last year, but a good refresher. Again, save pi for the end. Do it last, because we don't like decimals.
50.24 inches squared.
Good, approximately 50.24 inches squared. Lana, any questions at all on spheres and cylinders before we go? All right, your homework for the weekend is to do page 260 to 261, pages 260 to 261, the homework, numbers 1 through 19. Pages 260 to 261, the homework, numbers 1 through 19. Gentlemen, if you have any questions for me, be sure to let me know via email. I'll be happy to answer those, or if nothing else, I'll answer them on Monday when we come back to class. Looking forward to seeing you again. I know Lana has missed you, having to be the only one in here for class time and answering all the questions, so she's looking forward to having you back. But anyway, trust you'll get feeling better, trust Dad's doing better, and see you then.